Hey guys, Andrew here with Great Lakes Sprouts Media. Today we're going to be talking about tropisms. Tropo meaning to turn in Latin. So we look at trees, why do they grow straight up? How do they know to grow towards the light? How do the roots know how to grow towards the water? This is known as tropisms. We're going to look at some examples today. Let's go see if we can find some. Come on. All right guys, so tropisms, like I said before, means to turn in Latin. It's a response to an external stimuli. So we're looking at this tree here. You got smashed by another tree, kind of started growing crooked, and then it started growing straight. How does the tree know how to do that? So there's a term called gravitropism. So the upper part of the tree is known as the shoot, and then we got the lower parts known as the roots. So the shoot up here grows towards anti-gravity, so it's anti-gravitropic. The roots grow towards positive gravity. They're positive gravitropic. We have diagogeotropism, so when the plant knows how to grow diagonal or horizontal. Then we have plagiogeotropism, and the plant's stems know how to grow on an axis, like this. So there's a hormone in the plant actually called auxin. The auxin is what's known to be responsible. This is what botanists and scientists have found as a hormone to do these responses and build up and move towards these areas. Let's go look at another example here. We're gonna look at phototropism. Found this species in the woods. This actually is not native to Ohio. This is a yew tree or taxus. It's got those little red berries. You typically see in front of people's houses, trimmed to a perfect rectangular shape. Crazy story is I knew someone that worked for the, I'm not gonna say any names, for the Metro Parks, the zoo, and one of the zookeepers was driving to work the one day, saw a bunch of taxus sitting in front of someone's house. She didn't know what it was. She didn't identify it right. And she fed it to the kangaroos and ended up murdering all the kangaroos. They all died. Sad story, but you know, she did get fired. But you know, you gotta always make sure you know how to identify stuff. But I want to show you some examples with phototropism. That's what we're talking about today, is the tropisms. So you got this taxus here. It's probably pooped out by a bird flying across the sky. So see, we got the light up here. How does the plant know how to grow towards the light? It's phototropic. It'll start going towards that way because of the chemical we talked about before, the hormone auxin. You know, when we look at indoor plants, house plants, some have a low phototropic response rate. So we want to pick those for like indoor plants if we have a low light area, ones that aren't going to stretch and pull away. With phototropism, it's important to know this because if you plant a seed, it starts to etiolate, meaning to elong, and it'll stretch and become very weak. We don't want to do that. So you know, we can stop this problem by usually putting a light closer to the plants, especially for seeding stuff. You know, we don't want the plant stretching like that, but that's why plants know how to move towards sun. It's external stimuli, phototropism. It's in their DNA, they know how to do it. Also, there's one known as stigmatropism or stigma. The plant responds to touch. So sometimes you'll see a vine going up to another plant and starts wrapping itself around. This is an external stimuli to touch. There's a lot of different tropisms. There's chemotropism, and I can go on and on and on, but I'm talking about the main ones. So we also look at bonsai. It's really good to know the gravitropism, hydrotropism, all these things. This is how you can train your plant. So if I wanted to bend this over like this, slowly over time, eventually this main apical meristem will start bending up like this. And we can train this thing to go in any way we want. But what happens too, if we have low light, another hormone comes into play called gibberellin. It's actually named after a fungus. That's the first time they found this hormone, gibberella. So when you have, before like I was saying, when the plant's low light, it starts to stretch. We start to see elongation in between each internode. Also, it's another hormone they use actually in grapes. You ever see your wild grapes outside? You pick them, they're real tight together. They'll actually use gibberellic acid and spray it on the grapes to elongate the individual stems in between to give more room for the grapes to get bigger. You know, this is a good thing to know for selecting indoor house plants. And there you have it, phototropism. Let's go look at another example of a different tropism. So another main tropism is hydrotropism. This is when the plant's roots grow towards water. A lot of people have the misconception that the plant's growing towards nitrogen or fertilizer. It's going to take up whatever's in the water, whether it's toxic or good for the plant. The plant's just going towards the water. It doesn't go, oh, here's some nitrogen, here's some phosphorus. It doesn't know how to do that. Hydrotropism. It's really cool also with the tropisms we talked about, because imagine if you had to go take a seed and plant it perfectly the right way, thousands of seeds. It takes so much time. The plant knows, hey, roots going up, it's going to know to go down towards positive gravitropism, and the shoot's going to go up. The seed's going to be able to fix itself and stabilize itself and get itself in the right direction. What an incredible mechanism this has. So there you guys have it. We talked about tropisms, why they're important. We can use them for bonsai, we can use them for selecting plants, we can use them for training, all types of things, guys. Very important thing to know. If you guys have more questions, comment below. Don't forget the like and subscribe button, guys, and thanks for watching. We'll see you soon.